The universe was never supposed to surprise us this way. For more than a century, astronomers and cosmologists have pieced together the story of existence like archaeologists brushing away cosmic dust, slowly revealing a coherent timeline. It begins in darkness, in a moment where everything, space, time, matter, and energy, was compressed into a singularity so dense and so hot that the laws of physics as we know them break down. Then came the Big Bang, a name that hardly captures the profound unfolding that followed. In an instant, the universe expanded, cooled, and gave birth to everything that would ever be. Time began to flow. Space stretched. Light began its endless journey across the void. For generations, we've looked up at the night sky, confident that every star, every galaxy, every wisp of light fits somewhere within this grand timeline. But what if it doesn't? What if, somewhere out there, hidden in the dark and ancient fabric of space, there is something that shouldn't exist? Something that breaks the story we've so carefully written? Imagine a galaxy whose light whispers a date older than the universe itself. A structure that seems to predate time as we understand it. At first glance, it sounds absurd, an impossible paradox, like a riddle designed to mock our intelligence. Yet this is exactly the kind of puzzle astronomers faced when humanity's most powerful eye, the James Webb Space Telescope, turned its golden mirrors toward the distant past. James Webb was never simply built to look far. It was built to look back. Its infrared gaze was designed to pierce through cosmic fog, to see beyond what the Hubble Space Telescope could, and to uncover the universe's earliest moments. Every telescope before it had been like a lantern shining into a misty night. Webb is a torch. Its instruments are so sensitive that they can catch the faint, stretched whispers of light that have been traveling toward us for more than 13 billion years. With it, astronomers hope to glimpse the first galaxies being born, faint smudges of light from an era when the cosmos was only a few 100 million years old. They expected to see fragile, infant structures just beginning to take shape. But among the first images Webb sent back was something that made scientists stop in their tracks. Buried in the data was a signal that did not fit. It came from a galaxy later catalogued as Jade's GS Z13-0, a name as clinical as the discovery was extraordinary. Its light told a story that did not match our expectations. Based on its redshift, a measure of how much its light had been stretched by the expanding universe, it appeared to have formed just 320 million years after the Big Bang. That alone was remarkable. It pushed the cosmic frontier farther back than we had ever seen. But when astronomers analyzed the structure of this galaxy, when they calculated its brightness, they found something stranger still. This was not a fragile cluster of newly born stars, barely clinging together in the cosmic dawn. It was massive. It was bright. It seemed mature, too mature, for something born so early. It was as if, when expecting to find a newborn, they discovered a fully grown adult. The scale of this is difficult to grasp, so let's step away from cosmic numbers for a moment and imagine something closer to home. Picture yourself flipping through a family photo album. Each page takes you back in time, birthdays, school days, baby photos, until finally you arrive at the grainy ultrasound image, the very first glimpse of your existence. That ultrasound is the limit. There are no photos before it, because before it, you didn't exist. Now imagine that tucked in the back of the album, there's a crisp, clear photograph of you as an adult, dated years before you were born. Not a blurry mistake. Not a glitch. A perfect, undeniable image. The sense of wrongness would be immediate, a jarring break in the flow of your personal timeline. That is what astronomers felt when they saw Jade's GS Z13-0. According to the best models we have, galaxies like this should not exist so early. The cosmic album has a page we didn't know about. This discovery didn't happen in a vacuum. For decades, the backbone of cosmology has been the lambda-CDM model, lambda cold dark matter, the standard model of the universe. It lays out a timeline stretching back 13.8 billion years. According to this model, the universe began with the Big Bang, then, about 380,000 years later, cooled enough for atoms to form, releasing the cosmic microwave background radiation we still observe today. Over hundreds of millions of years, matter began to clump under the pull of gravity, forming the first stars and galaxies. Small structures formed first, then merged into larger ones over billions of years. This isn't guesswork. It's supported by decades of observations, simulations, and the extraordinarily precise measurements of the cosmic microwave background. It has been, until now, a story that fit together beautifully. And then Webb looked deeper. Jade's GS, Z13-0 wasn't alone. Several other bright, massive galaxies emerged from those first images, all existing within a few 100 million years of the supposed beginning. It was as if the early universe had been building galaxies on fast forward, assembling complex structures in a fraction of the time our models say is possible. To put this into perspective, imagine building an entire bustling city overnight, a skyline, infrastructure, homes, highways, all fully operational by morning. The numbers simply don't add up. Astronomers were forced to consider the possibility that either their understanding of early galaxy formation was incomplete, or that something far more fundamental was wrong. The excitement was palpable. Within weeks of Webb's first deep-field images being released, papers flooded the scientific community. Some argued that the galaxies were smaller than they appeared, their brightness perhaps boosted by gravitational lensing, where a closer object bends light and magnifies the background. Others proposed that star formation in the early universe might have been far more efficient than we've accounted for, perhaps driven by exotic population 3 stars, massive, short-lived, and blazing hot, that could have quickly seeded galaxies with light and structure. A few even suggested that the universe itself might be older than we think, perhaps by hundreds of millions of years. If true, this would rewrite cosmic history from the ground up. If you find yourself drawn to these mysteries, if you're fascinated by how one distant speck of light can unravel the deepest assumptions about existence itself, then you're in the right place. The journey ahead isn't just about data. It's about reshaping how we think about reality. And if that excites you, stay with us. There are more forks in this cosmic path to come. To understand why this discovery hits so hard, we need to grasp how astronomers measure cosmic time. The further away something is, the longer its light has been traveling to reach us. Light from the sun takes just over 8 minutes. Light from the nearest star takes over 4 years. Light from the Andromeda Galaxy takes 2.5 million years. Webb, however, is catching photons that began their journey more than 13 billion years ago, when the universe was just a fraction of its current age. Over such distances, the expansion of space stretches light, shifting it into the infrared spectrum. This is why Webb's infrared capabilities are crucial. It can see light that has been stretched to invisibility for ordinary telescopes. When scientists detect a galaxy with a redshift of 13, they are essentially looking at a time when the universe was only about 2% of its current age. And that's what makes Jade's GS Z13-0 so confounding. To exist in that era with such mass and luminosity, it must have formed stars, assembled matter, and organized itself at a rate that defies our current physical models. The cosmic recipe seems to be missing an ingredient, or perhaps the oven was far hotter, faster, and stranger than we thought. Consider this. Galaxies like our Milky Way took billions of years to reach their current scale. Even the earliest known galaxies before Webb appeared relatively small and dim, in line with our expectations. Suddenly, Webb's mirror peers through time and sees something bright and structured staring back. It's as though you were watching a time-lapse of a tree sprouting from a seed, and instead of seeing it grow gradually, it jumps from a sprout to a 100-year-old oak in a single frame. The rules of growth appear violated. As this revelation unfolded, it didn't just shake scientists, it electrified them. Moments like this are rare in science, when an observation so clean, so unexpected, forces everyone to rethink their frameworks. It's easy to imagine astronomy as a static field, full of fixed facts about distant stars. In truth, it is a living story, and sometimes the story changes overnight. It's here that we must pause and reflect on what it truly means to see this far back in time. Every photon Webb detects from Jade's GS Z13-0 has been traveling toward us since long before our planet existed. These particles of light began their journey before the sun formed, before the Milky Way completed even a single revolution. For 13 billion years, they crossed an expanding universe, passing through epochs of darkness and light, through regions of space that may have since transformed completely. They are messengers from a time we can barely imagine, carrying with them the secrets of their origin. And when they finally arrived, they told us something we didn't expect to hear. There's a quiet poetry in that. A single galaxy, unimaginably distant, has forced humanity to question the timeline of everything. That's the power of looking into the deep cosmos. It's not just about finding things. It's about finding things that don't fit. If discoveries like this ignite your curiosity, if you feel that pull toward the horizon of the unknown, then make sure you journey with us as we continue deeper. There are more layers to peel back, more possibilities to explore, and the further we go, the stranger it gets. Astronomy thrives on mysteries, but some discoveries don't just raise questions, they multiply them. The existence of a galaxy so massive and luminous, so early in cosmic history, doesn't merely challenge one theory. It forces us to reconsider a network of interconnected ideas. Every timeline, every simulation, every neat diagram showing the universe's orderly evolution trembles at the edges when faced with something that should not be there. What makes this particular paradox so potent is that it doesn't just sit at the frontier of observation. It reaches into the very foundations of cosmology itself. In the days and weeks after Jade's GS Z13-0 was announced, the scientific community responded like a shaken hive. Astrophysicists, cosmologists, and theorists began proposing explanations, some conservative, some radical. At first, many turned to the simplest possibility. Perhaps Webb's instruments, though revolutionary, had somehow been misled. Could the brightness of the galaxy have been boosted artificially by a cosmic trick? One such trick is gravitational lensing, where a massive object, like a cluster of galaxies, sits between us and the distant target. The foreground object bends the fabric of space-time, magnifying and distorting the background light. If some hidden lens lay along the line of sight, Jade's GS Z13-0 might not be as massive as it appears. It could simply be a small, faint galaxy whose light has been stretched into prominence by a cosmic magnifying glass. It was a comforting thought. It didn't require rewriting physics, only adjusting for a chance alignment. But as astronomers carefully analyzed the data, this explanation began to unravel. No obvious lensing object could be identified in the region. The shape of the galaxy's light, too, didn't match the characteristic arcs and distortions typical of lensing. Though not entirely impossible, the gravitational lensing hypothesis grew thinner with each analysis. The galaxy's apparent brightness and mass seemed to be intrinsic, not borrowed. Next came the idea that perhaps the galaxy wasn't actually as distant as it seemed. Redshift measurements, after all, can sometimes be tricky. Spectroscopic confirmation, analyzing the exact wavelengths of light to nail down a precise distance, is the gold standard, but early Webb discoveries relied heavily on photometric redshifts, using the brightness across different filters to estimate distance. Could this galaxy simply be closer than we thought, masquerading as a primordial relic due to some quirk of light? Follow-up spectroscopy was crucial. When it arrived, it confirmed the original measurements. This galaxy truly was from the cosmic dawn, not some interloper pretending to be ancient. The simplest explanations were slipping through astronomers' fingers, one by one. With observational errors and gravitational tricks largely ruled out, attention turned to the physics of the early universe itself. Maybe galaxies could form faster than we realized. Our models of galaxy formation are grounded in decades of simulation, but simulations are, by nature, simplifications. They rely on assumptions about how gas cools, how stars ignite, how dark matter collapses. If any of these assumptions are even slightly off, the entire timeline shifts. One key area of uncertainty lies in the behavior of dark matter during the universe's infancy. According to Lambda-CDM, cold dark matter began clumping first, creating invisible gravitational wells that pulled ordinary matter in behind it. But what if this process was far more rapid than we believed? If the first dark matter halos formed earlier or collapsed more efficiently, they could have jump-started galaxy formation, allowing massive structures to arise shockingly fast. Another factor is the nature of the very first stars, the elusive population 3 stars. These stars, forged from pristine hydrogen and helium with no heavier elements, were unlike any stars that exist today. They were colossal, some hundreds of times the mass of the Sun, burning ferociously and living briefly. Their intense radiation could have reionized surrounding gas and triggered rapid star formation in their wake, creating a domino effect that led to galaxies blooming like sudden fireworks. If population 3 stars were more common or more extreme than our current models allow, early galaxies might have formed with unprecedented speed and brightness. In this scenario, Jade's GS Z13-0 isn't a mistake in the cosmic timeline. It's evidence that the universe's earliest moments were more dynamic and efficient than we ever dared to imagine. But even this explanation has its limits. The amount of mass contained within that galaxy is staggering for the era it occupies. To assemble that much matter in just a few 100 million years would require a cosmic assembly line operating at near-perfect efficiency. Gas would need to collapse almost instantly. Stars would need to form in massive numbers without blowing the galaxy apart with their own radiation, and the process would have to repeat itself on scales our current physics struggles to accommodate. It's possible, but it stretches the boundaries of what we think is probable. And when the probable begins to stretch too far, scientists start wondering whether the underlying picture itself needs changing. This leads us to the most unsettling possibility of all, that the standard cosmological model might be incomplete, or even wrong in some of its foundations. The Lambda-CDM model has been remarkably successful at explaining the large-scale structure of the universe, the cosmic microwave background, and the distribution of galaxies. But cracks have appeared before. The current tension between measurements of the Hubble constant, how fast the universe is expanding, is one example. Local measurements using supernovae and distant measurements using the cosmic microwave background don't match. Some researchers believe this hints at new physics lurking beneath the surface. If the universe is actually slightly older than 13.8 billion years, say by a few 100 million years, it could provide extra time for galaxies like Jade's GS Z13-0 to form. That may sound like a small adjustment, but it would ripple through cosmology like a seismic shock. Imagine altering the date of your own birth by a year. Suddenly, every event in your life shifts. Your age during key moments changes, timelines rearrange themselves. In the cosmic sense, shifting the age of the universe affects everything from the formation of stars to the expansion rate to the interpretation of ancient light. It's not something cosmologists propose lightly. But Webb's discoveries have emboldened some to explore models where the early universe behaves differently, perhaps driven by a new form of dark energy, or an early phase of inflation that lasted longer than we thought. And then there are those who step even further beyond the edges of the map. Some theorists have proposed that what Webb has uncovered are not galaxies within our universe's timeline at all, but fossils from a previous cycle of cosmic existence. In cyclic cosmological models, the universe doesn't begin with a singular Big Bang and end in a distant heat death. Instead, it expands, contracts, and rebounds endlessly. Each bounce seeds the next universe with the remains of the last. If something like this were true, then finding a galaxy whose light seems to predate the Big Bang might not be a paradox at all. It might be evidence, however faint, of a cosmos that existed before ours, leaving behind subtle fingerprints that Webb is just sensitive enough to catch. These ideas are speculative, but that's how scientific revolutions often begin. An anomaly resists explanation. Conservative fixes fail. Gradually, the door opens to new frameworks. In the early 20th century, The observation of galaxies moving away from us forced the radical realization that the universe is expanding. In the late 20th century, unexpected dimming of distant supernovae revealed the existence of dark energy. Each time, the universe whispered something we didn't want to hear, and when we finally listened, everything changed. Perhaps this is another one of those moments. At this point, the implications cascade outward like falling dominoes. If galaxies like Jade's GS Z13-0 are common, then our understanding of cosmic structure formation must be rewritten. If they are rare but real, they might point to special regions of the early universe where conditions were extraordinary. If our timeline is wrong, then every cosmological measurement we've made needs to be recalibrated. And if none of these explanations suffice, then we may be standing on the threshold of a new era in cosmology, one where the very fabric of time, space, and cosmic history is more complex than we ever imagined. When confronted with such possibilities, the human response is a mix of wonder and unease. On one hand, it's exhilarating to think that we might be witnessing the beginning of a paradigm shift, that our generation may live through a reimagining of cosmic history. On the other, it's humbling to realize how fragile our current understanding might be. We have built intricate mathematical castles, but the universe has a way of revealing hidden rooms we never knew existed. If walking through those hidden rooms excites you, if you want to follow this story as it bends into the unknown, then stay with us. There are still more doors ahead, and the next may open onto something even stranger. What makes this period especially electric is that James Webb is still at the very beginning of its mission. Each new deep-field image is like a fresh page in a book whose ending we can't predict. The galaxies already identified might be only the tip of the iceberg. Deeper observations, longer exposures, and follow-up spectroscopy will push our view even further back. If anomalies like Jade's GS Z13-0 keep appearing, the pressure on existing models will grow. Scientists will be forced to either stretch their theories to fit the data or to build new ones altogether. It's worth remembering that cosmology is a relatively young science. Barely a century ago, most people thought the Milky Way was the entire universe. Barely a century ago, the idea of an expanding cosmos was revolutionary. In that sense, we might still be standing on the shoreline of a vast cosmic ocean, mistaking the nearest waves for the whole. Each discovery is a lantern pushing that shoreline farther back, revealing more of the infinite. It is not a sign of failure when models break down. It's a sign that we're learning something profound. The discovery of a galaxy that seems older than the universe doesn't necessarily mean the universe itself is wrong. But it does mean our story about it is incomplete. Perhaps galaxies formed in furious bursts that our models haven't captured. Perhaps the early universe was governed by physics that we have yet to uncover. Perhaps there were worlds before our world, and we are seeing their fading light. Each of these possibilities leads to different futures for cosmology, different questions, and different kinds of wonder. The moment we confront something that doesn't fit into our cosmic story, we stand at a crossroads. On one side lies the comfort of established theory, the well-lit path where we adjust a few parameters, tighten a few equations, and bring the anomaly back into line. On the other side lies the unknown, a dark forest of possibilities where the rules might be different, where our story of time, structure, and origins may need to be rewritten. Jade's GS Z13-0 sits at that fork, its ancient light spilling across space, daring us to choose which way we will walk. If the galaxy is real, massive, and as old as its light suggests, then our understanding of cosmic evolution faces three broad possibilities. The first is that our current models are mostly right but incomplete. The second is that our cosmological timeline itself requires revision. The third, more radical, is that this galaxy is not simply part of our universe's timeline at all, but a trace of something that existed before it, or beyond it. The first path, the conservative one, imagines that galaxies formed far faster and more efficiently than we thought. This would mean revising our models of star formation, gas cooling, and dark matter behavior in the earliest eras. Perhaps the primordial universe was a hyperactive nursery. Clouds of gas collapsed under gravity at astonishing speed, feeding off dense pockets of dark matter. Population 3 stars, massive and brilliant, may have ignited like cosmic matchsticks, burning hot and dying young, seeding the surrounding space with metals and triggering cascades of new star formation. In this scenario, Jade's GS Z13-0 isn't a relic of a previous universe. It's evidence that our picture of the early one is simply too tame. Instead of a slow, tentative dawn, cosmic history began with a roaring blaze. If this is the case, then future Webb observations should uncover many more galaxies like it, not as outliers but as representatives of a busy, crowded early cosmos. This would reshape how we understand galaxy evolution, supermassive black hole formation, and even the timing of cosmic reionization, the period when the first stars flooded the universe with radiation, transforming its opaque fog into the transparent expanse we see today. It would be a profound but elegant adjustment. The story remains the same, but its opening chapter is more dramatic than we imagined. The second path is less gentle. If the universe itself is older than we think, then the timeline stretching back to the Big Bang must be redrawn. This would mean our measurements of cosmic expansion, based on the cosmic microwave background and distant supernovae, are missing something crucial. Perhaps the early universe experienced a phase of expansion or behavior we have yet to detect. Perhaps dark energy or some unknown field influenced the pace of time itself in the earliest moments. A universe even a few 100 million years older would give galaxies like Jade's GS Z13-0 time to form naturally. But this adjustment would ripple outward. It would force us to rethink the Hubble constant, the cosmic background, and the delicate balance between matter, radiation, and dark energy. It would not be a small correction. It would be rewriting the first line of the cosmic script. And then there's the third path, the one that stretches beyond the edge of our maps. What if this galaxy truly is a fossil, not from our timeline but from another? Some cosmological models propose that our universe may not be the first, nor the only. Cyclic models envision universes expanding and contracting over infinite eons, each new Big Bang seeded by the ashes of the previous cosmos. In such a model, structures from a prior cycle could, in theory, leave faint imprints that survive the bounce, traces written into the geometry of space-time itself. If Jade's GS Z13-0 or objects like it are such imprints, then Webb might have stumbled upon evidence of a pre-cosmic archaeology, relics not from the early chapters of our universe, but from an entirely different book. There are even bolder speculations. Some physicists consider the possibility of a multiverse, a vast sea of universes bubbling into existence through eternal inflation or quantum fluctuations. In such a landscape, some universes could bleed into others through subtle interactions at their boundaries, leaving behind artifacts like ancient galaxies that seem out of place. If this sounds fantastical, remember that just a century ago, the idea of other galaxies beyond the Milky Way was considered outrageous. The universe has a way of expanding not just in size, but in imagination. These three paths, hyper-efficient formation, revised timelines, and pre-cosmic relics, aren't mutually exclusive. Reality could weave elements of all three. The early universe might have been both older and more productive than we thought, while also carrying echoes of something deeper still. The truth may not fit neatly into a single box. It rarely does. As scientists explore these possibilities, they do so not with certainty, but with curiosity. Telescopes like Webb are tools of both discovery and humility. Each image they capture is a conversation between light and time, between what is known and what resists knowing. With each new dataset, hypotheses will be tested, some discarded, others refined. Perhaps future deep field surveys will uncover hundreds of similar galaxies, revealing a bustling early universe. Or perhaps Jade's GS Z13-0 will remain an outlier, a single enigmatic whisper pointing towards something vast and hidden. If following these forks in the cosmic road excites you, If you feel that pull toward the mysterious places where science meets imagination, then stay with us. The next revelation may be closer than you think. Beyond the scientific implications, this discovery touches something deeply human. It forces us to confront how small our current understanding truly is. For centuries, we have tried to map the heavens like cartographers charting an ocean. Each advance in technology pushes the boundary a little farther, and each time, we discover that the ocean is vaster than we ever dreamed. The James Webb Telescope has pushed that boundary again, not just in distance but in time. It has allowed us to look back so far that we risk glimpsing the edge of our own narrative. And standing at that edge, we have to ask ourselves, what does it mean to find something older than the universe? What does it mean when the story we tell about our origins is incomplete? For some, these questions may provoke discomfort. We like beginnings to be clear and endings to be neat. But the universe is under no obligation to satisfy our narrative instincts. It unfolds according to its own rhythms, its own hidden logic, and our task is to listen, to observe, and to adapt our understanding to its truths, no matter how strange. There's a humbling beauty in this. To look at a galaxy like Jade's GS Z13-0 is to look at light that began its journey before the Earth existed, before our sun coalesced, before any creature walked or breathed or dreamed. And yet, through fragile instruments and collective human effort, that light has finally reached our eyes. It carries with it a message, not in words, but in its very existence, that reality is richer and older than we thought. It reminds us that our place in this cosmos is not as masters or narrators, but as curious listeners in a vast, ancient choir. If you've followed this story this far, if you've let your imagination drift with these ancient photons, then you're already part of that listening. You're part of a community that stands on this tiny blue planet, looking into the darkness not with fear, but with wonder. And if you want to keep walking deeper into that darkness with us, if you want to follow the next branching path, join this journey. There are more galaxies waiting, more paradoxes to unfold, more whispers from the beginning to catch. As Webb continues its mission, the data it gathers will stretch our imaginations even further. Deeper fields will reveal galaxies at higher redshifts. Spectroscopy will refine distances. New anomalies may appear, each one a puzzle piece that could either fit neatly into place or force us to redraw the picture entirely. The next decade may witness a transformation in cosmology, as profound as the shift from a static universe to an expanding one. We may find that galaxies like Jade's GS Z13-0 are plentiful, reshaping our models of star formation. Or we may find only a few, pointing toward some extraordinary prehistory we have yet to comprehend. Either way, the universe has already made its first move. It has shown us something unexpected. The rest is up to us. And this brings us to the most profound reflection of all, the relationship between knowledge and mystery. Every discovery expands what we know, but it also expands the perimeter of the unknown. Like explorers reaching a new shore, we find not an end, but a new horizon. The discovery of a galaxy older than the universe is not a conclusion. It is an invitation to rethink, to explore, to embrace the strangeness of existence itself. It is a reminder that, for all our equations and instruments, the cosmos is still larger than our capacity to fully contain it. As the light from Jade's GS Z13-0 fades into the blackness of the deep field, we are left with a choice: to retreat into the safety of what we think we know, or to step forward into that vast, beckoning unknown. The galaxy's light has traveled for over 13 billion years to reach us. It crossed epochs, expansions, and transformations. It endured unimaginable distances and timescales. And now it has arrived, not to give us answers, but to ask us better questions. The universe is not finished speaking. It never is. Each question leads to another. Each discovery opens a new chapter, and the story unfolds endlessly, like light racing across the void. The galaxy that seems older than the universe is not just a scientific puzzle. It is a mirror held up to our curiosity, reflecting both how far we've come and how far we still have to go. And perhaps, in that reflection, there's a kind of quiet grace. We are tiny beings, orbiting an ordinary star in a small corner of a galaxy, yet we have built eyes that can pierce the dawn of time. We have dared to ask questions that stretch across billions of years. And though the answers remain elusive, the act of asking, the act of listening, binds us to the cosmos itself. This is not the end of the story. It's just one of its earliest pages being read anew. The light has reached us. The question has been asked. Now we step forward into the dark together,